All right, Math 8. Today we are going to go through probability portion of the unit, lesson number 1, which is about determining probabilities using tree diagrams and tables. Last time we did a brief review regarding what is a probability, how we can find a brief probability using a deck of cards like 52 cards, using shape, coin, some notion like P bracket open, head bracket close, if we're talking about the coin head and tail, those kind of little stuff. Today we are going through a little bit more in detail, more regarding something we like to call it as a sample space. So first thing first, when we talk about probability, we need to understand that few events can happen. And whenever there's few events that happen, the first event do not affect the other events. There are some exception comes out when it comes to high school mathematics. However, independent event, long story short, it's all about the results for which the outcome of one event has no positive or negative effect on the outcome of another event. One example is, for instance, imagine you're tossing a coin that has head and tail. If I flip a coin, and let's say I flip the coin total 5 times. If the first outcome was head, second outcome turned out to be head, third outcome turned out to be head, that does not mean we have guaranteed probability of fourth toss to be head. It can be tail, or it can also be head just because theoretically it is 50-50 chance. However, even though we are not talking about experimental probability here, you need to understand that coin toss always is a good example to elaborate that previous outcome does not affect the current outcome, which will not affect the future outcome. Same thing happens if you roll a die. If you roll a 6 on the first roll, the likelihood of rolling a 6 on the second is not affected by the first one. It's going to be 1 out of 6, just like the previous one. So what is a probability? Probability is about a chance of happening something, result in something. For instance, if we talk about head and tail for about coin tossing, you know that head theoretical probability is 1/2, tail also 1/2. So we start with fraction as a ratio, and obviously if you multiply those by 5, then you will get 5 out of 10, 5 out of 10, which means it's going to turn into 0.5, 0.5. Thus, decimal representation is possible. And whenever you have decimal multiplied by 100, that means you can have percentage. And at this level of math in grade 8, it doesn't surprise. We learn about ratio, rate, and when it comes to either of those, we can start with the fraction, which can turn into decimal, which can turn into percentage. So let's getting into the real lesson portion here. What is a sample space? Sample space is literally listing every single possible outcomes in a given situation. I put it the word of a probability experiment, or I like to say a given situation with some kind of tool. In this case, tools, because we are going to go through an example that have a tool, but because we are running more than once, it's gonna be like a identical tools, is as if you're using the same thing twice. For example, coin toss twice is a fancy way of saying two of the coin flipping at the same time. Rolling two dice is equivalent as rolling a die twice. So let's look at this. In your booklet, you have a class example, a pointer and a spinner. In this case, spinner, color is indicated: green, red, orange, and blue. I want you to divide this space into two, like the one that you see in the screen like this, because one on the left side I'm going to use a tree diagram. The second one I'm going to use table method. It doesn't matter which one you choose. So let's think about theoretical probability. What I mean by probability in this case is probability of a color. There are 4 different colors, so normally the total goes at the bottom and whatever you desire going to the top. I do not have any of the overlapping color, like for example red, green, orange, blue. All of those do not have anything identical. If it's, let's say, happen to be red and red, then it's going to be 2. Right now, however, we only see each one of the color, which means it's 1/4. Now, why am I calculating this theoretical probability first? Is because when we talk about tree diagram, it is important for understand about this 4 total as a number of branches. And I'm going to elaborate what I mean by that. What I mean by that is you're starting with the 4 branch choices in this situation. I have red, I have green, I have orange, I have blue in this case. Note the fact that the first column that you see here is landing result number 1. First landing, if you will. And it makes sense why we have 4 choices because, well, theoretically, we have each of those section, and that's the possible outcomes that you can think of. Now, in this case, imagine you're running a second landing, aka you did it twice. That means you're gonna have 4 branches again out of each possibility. So what do I mean by that? Red can have another red. Red can have, however, green next. Red can have orange after, or blue. And this result that you have can be represented as bracket R, 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 G, R, or R, and so on. Those are what you have. And I want you to list every single possibility on the right side. Same thing. Gonna skip to the conclusion soon, but you can actually write all of these actual outcome on the right side. Order doesn't really matter, but it's still a good idea to be consistent. Now, imagine you list all of the outcome on the right side. What we can do afterward is count every single outcome. Long story short, you figure out that each of the 4 branch will be broken down into 4 sub branches. That means we will have 16 total outcomes. That is how we use, or how we can use, tree diagram. Now let's use a table method. Before I elaborate table method, let's talk about table a little bit. Do not write these things yet. Table is normally if you have X, Y, 2 different type, and you're elaborating any possibility for that X input and how X input result in Y input, which means tables normally used in the world of science. As an example, there is independent variable, aka manipulative variable, something that you change on purpose in the experiment, and you try to observe so what happened afterward if you change that X, which we call a dependent variable, or in science world, responding variable. So in this situation, it's kind of ironic because we just mentioned that there's assumption in this unit, and it happened because theoretically the first outcome doesn't affect the second outcome. There should be no relationship between first outcome to second. So how can we use it? Well, this is how you use it. Now you can copy some of the outcome, ladies and gentlemen. I like to use my horizontal column, spin number 1, vertical spin number 2. And like my rationale in previous slide, you have red, green, orange, blue outcome, ladies and gentlemen. So you have RG or B, but at the same time, your second outcome, which is identical as a first outcome, you are setting the exact same thing. Here's the problem though. If I use different object like coin, then the table will be a little bit smaller. And once you make that table, all you gotta do is literally fill this blank, ladies and gents. This part is a bit tedious. Personally, I like the table method just because I'm a science teacher also, and I use tables way more in real life, but that doesn't mean you have to use table method. But as you can see, there is a specific probability that I'm looking for. It will come out if you match those X and Y axis, if you will, and you can conclude that everything that you see is 16 as a total. So the probability is 1 out of 16. Some people may wonder, is there any better way that I can solve probability question when there's more than one event? The answer is yes, there is. So this may blow your mind a little bit. There's a algebra method that you can use. Let's think about the scenario. The scenario saying I have 2 of an event. As soon as I read the context, which is this picture over here, I found that the first event and second event, they do not really interact each other. The relationship do not exist. So that means I can find the ratio of the first one, ratio of the second one, and actually combine them together. What I mean by that is probability of red, and I'm gonna multiply with another probability of red. Some people may wonder, Mr. Kim, why are you multiplying those two probabilities together? The reason is actually simpler than you think. Think about what I mentioned about branch method, tree diagram method. Out of the total choices that I had 4 branches, which broken down into another 4 branches. So it resulted in 4 times 4. So mathematically, what that means is probability of red, which is 1 over 4, and probability of 1 over 4, if you multiply them together, these denominator, 4 times 4, which becomes 16, and 1 on the top, it makes that 16 as total sample space value, and the 1 is whatever the event that you're desiring to see. In this case, red and red. So probability of red and red is 1 out of 16. If I calculate this using a fraction, 1 divided by 16, which gives you 0.0625, and if you multiply by 100, it becomes 6.25%, and boom, that's how you can find the probability algebraically. And you can use it for as many as you can. Like, for example, imagine the questions keep saying, what about the third outcome as blue? Then you do 1 over 4 again. Or sometimes it's going to get tricky. What about blue or green? Then the outcome become 2 out of 4 for that one, and you can still multiply. We're not going to do those tricky example at this moment. All right, so what is our next goal? Well, our next goal is doing homework problem regarding what we learned, sample space. Every question should be available in textbook page 416 to 418. I want you to do 5 questions, which I put it as 3, 4, 5, 6, 7. And that was today's lesson.